In this problem, we'll solve a system of equations using the substitution method. We'll solve the system x plus 2y equals 5, x plus y equals 2. Now the substitution method requires us to solve one of these equations for one variable in order to substitute in for another variable. And neither of these are solved for x or for y, and I can choose which one I want to solve. I'll solve the first one for x. Pretty directly I can do that. Since x plus 2y equals 5, I know that x equals, subtracting 2y from both sides, the opposite of 2y plus 5. Now, I solved the first equation, I'll call that equation 1, for x. So I want to substitute this value into the other equation, which I'll call equation 2. So my equation 2 said x plus y equals 2, but x is the opposite of 2y plus 5. So where I have an x, I put the opposite of 2y plus 5 for the x, plus the y equals 2. Now I'm going to solve this for y. I have the opposite of 2y plus 5 plus y equals 2. I can remove the parentheses because there's nothing in front of them. Combining like terms, I have the opposite of y plus 5 equals 2. Subtracting 5 from both sides, I have the opposite of y equals negative 3. And multiplying both sides by negative 1, I have y equals 3. Now it's tempting to stop there because we have y equals 3, but that's not the solution of the solution of the system of equations. We need an ordered pair. In other words, we found y, but we need to find x. Now we could put 3 in for y in this equation or in this equation, but since this one is already solved for x, I'm going to use this equation, x equals negative 2y plus 5, to find x. Substituting 3 for y, I have x equals negative 2 times 3 plus 5, or x equals negative 6 plus 5, or negative 1. Now I found a value for y and I found a value for x. I have as a possible solution the ordered pair, and I want to list x first because it comes first alphabetically, negative 1, 3. Whenever you're taking a test, you do not have to turn this in without knowing for sure it is the solution, because you can substitute negative 1 for x and 3 for y in both of these equations. Let's do it quickly. Negative 1 plus 2 times 3 is negative 1 plus 6, that's 5. That checks. Negative 1 plus 3 equals 2. That checks. Since this makes both equations true, it's the solution of the system, and you can state with a good sense of confidence that this is the solution to the system.